Hello, and welcome back to another video of Calc Nerd. After quite a few requests and a little bit or a lot of time in some cases, I've finally made my own working version of chess. So this is a two-player version of chess. You'll hand the calculator back and forth between two players. And before I show you the program, I'd like to note a couple of things. First of all, it does not have castling included in the program, which is where you switch your king and your rook if there's no pieces in between it. I just didn't include it at this time because I wanted to get the video out for you guys, but I could possibly update that in a future version. And then the other thing is that the program does not check to see if your king is put into jeopardy, which is called check. Your king is threatened, or checkmate if it's the end of the game. Just because, first of all, it would take quite a bit of computing power for the calculator to spit back an answer, and also quite a bit of room on your calculator. So I just decided against doing that. You'll have to have a little bit of chess knowledge to play the game of chess, but you probably will in the first place anyways if you're watching this video. So without further ado, let me show you the chess program. Okay, so I'm going to go ahead and click enter to run program chess. As you can see, it is drawing our two teams, which are uppercase and lowercase. Over here is the turn indicator, so that X will move to lower when it's lowercase's turn. All the pieces are represented by the first letter of their name, so like rook, king, bishop, and then the I's on both teams are kings, and the K's are knights. So you can use the arrow keys to move the cursor around the board. Once you get on top of the piece you would like to move, you click enter to select it, and then enter to wherever you want to go. You can see a little asterisk right there that shows you which piece you currently have selected. So let's say I decide not to move that pawn. I can then click the delete key, and that will take me back to that pawn, and I can select a different pawn if I'd like to move that. Then just click enter, and it'll move and change the turn indicator. So then, like, I don't know, for example, I'll move this knight out. Click enter there. And then I'll do a different move for uppercase just so I can show you that taking pieces is just like normal. So this knight can move in the little L shape. So then if I click enter, it takes that pawn. So it's really as simple as just playing normal chess, just moving the pieces around, doing all that. Remember the delete key to, if you want to change pieces, you already have one selected and you want to do something else. Then, in a special case, if a pawn reaches the other side of the board, it gets promoted to either a rook, knight, a bishop, or a queen. So you can select between those four with these four buttons right here. So if a pawn were to reach the other side, you'll kind of see that it moves, but the asterisk stays there, and that's indicating that it wants you to use one of these four buttons to select. So it's just like it would be on the board. So the math button will go to the rook, apps to the knight, program to a bishop, and the vars or vars button to a queen. And that's really all there is to the game of chess. So without further ado, let me show you a quick time lapse, and then we'll get right into the code. Okay, let me go over and edit program chess. So, for anyone who is new to programming on a calculator, a lot of the commands that I'll be using, you can click the program key, and a lot of them, like an if, then, else, for, we'll be using, stuff like output and get key, all that sort of stuff is found in just by clicking the program button, and you can click clear to exit out of that. And then some of the stuff like matrices, like this 2 brackets and an A, don't actually type that in. Go second and X to the negative first. That'll bring up the matrix menu, and as you can see, matrix A is right there. And then if you scroll over by using the right arrow key here to the math menu, there's stuff like dimensions, and we'll be using a fill command later on. So that's where you can find most things. And if you can't find a command or anything like that, click second and 0 to bring up the catalog, which is an alphabetical list of most of the things on the calculator. And so let's say I need something in the I's. I can click the button, the X squared button corresponded with I. And the first thing is I itself, the square root of -1. So that's that. Now let's keep going with the program. So clear home, del var matrix A, 8, 8 store into the dimensions of matrix A. Del var L1, 8 store into the dimensions of L1. Then we have a list of numbers here, and basically what this is, these are our pieces. So 2 corresponds with the lowercase, and I'll subtract 1 in the for loop right down here to get our uppercase ones. But basically the 0.2, 0.3, 0.4 of stuff like that is made so that when I call 10 times the fraction part, so that would return a 3 or a 4 in this case, or a 5 in that case, if I did 2.5, then I can figure out what type of piece it is. So like 2.2 is going to be a rook, or 2.6 is going to be, I believe, the king. So yeah, 2.6 would be the king, and then the queen would be 0.5. So that's how that works and what that's for. For x, 1, 8, L1 at x store into matrix A at 8, x, 2.1 store into matrix A at 7, x, 1.1 store into matrix A at 2, x, and L1 at x minus 1, so that's where it doesn't become 2.1, but it would become 1.1, which actually happens here, but any of the other ones go in through here. And 0.1 is the pawns, just so you know, so I just put the pawns in a separate row, and it just does that all the way across. And del var L1 for x, 1, 8, output at x, 9, quote, one of the brackets, which can be found by clicking second and the minus key right here. And then end for y, 1, 8, for x, 1, 8, I part of matrix A at y, x is equal to 2. So that's just a statement, and that will either return a 1 if it's true, or a 0 if it's false, which you can see I use answer right here. So that's answer would be the value of this, whether it's 0 or 1. So if it is indeed true, if wherever we are at matrix A, the integer part, so not the point whatever, it'd be the first part of the number, the actual part, not the decimal, I should say, then it's going to add 6, so we can actually get over into our lowercase letters over here. So I'm not going to go through that and read all of that, but if you'd like to change any of the characters in here, feel free to do so. In fact, if you wanted to do like a comma or, I don't know, like a multiplication symbol, you just type it in right there. Just make sure it's the same amount of characters, and you have one for each, and they're distinguishable, so you don't get lost in figuring out which pieces are which, and there'll be multiple places where you'll need to replace that. But feel free to do so. This program is customizable, I suppose you could say. And then to ends, output at 1, 11, quote, chess. Output at 3, 10, quote, upper, a colon, and then the X, indicating whose turn it is. Output at 5, 10, quote, lower, and then a colon. For x, 10, 16, for y, 1, 3, output at 2y, x, quote, the minus sign, so that draws that nice little border over here. Two ends, del var L1, 2 store into the dimensions of L1, fill 16 into L1, 1 store into t, 4 store into y, and answer store into x. Repeat until k is equal to 45, repeat until k is equal to 105, and, which is indicated by multiplication here, and the I part of matrix A at y, x is equal to t, which is the turn indicator. It's either 1 or 2, and it just keeps going back between that. So I'm just able to tell whose turn it is, and it also corresponds with the piece number, which makes stuff pretty easy. And then all that together, and then the addition is an or k is equal to 45, which is the clear button right here. Get key store into k. Output at y, x, quote, the plus sign. If the sum of k is equal to 24, 25, 26, 34, so if k is equal to any of these values, which correspond with all the arrow keys right here, then we're going to want to take the I part of matrix A at y, x is equal to 2. That's our statement again. If you want to change any of the characters, remember, feel free to do so, and there'll be a couple more spots where we'll have to do that. And then it's just all the rest of that statement, and make sure you do include all the commas and everything in here, because the program will not work if you miss any of those. min 8, comma max 1, comma y plus k is equal to 34, minus k is equal to 25, stored to y. Min 8, comma max 1, comma x plus k is equal to 26, minus k is equal to 24, stored to x. So that's the movement code. Like if you press the up arrow, which is 25, then basically it's just saying, okay, since you pressed 25, which corresponds right here, we're going to subtract 1 from y, which moves it up. That's basically how all that works. Output at y, comma x, comma quote a plus sign, and then two ends. If k is equal to 45, return, which just brings us out of the loop and then eventually exits the program. 10f part of matrix A at y, comma x store into C, and I will explain what that does when we actually get to our pieces. You'll see in just a minute. Y store into A and x store into B. Repeat until k is equal to 1 or k is equal to 23. Get key store into k. If sum of k is equal to 24, comma 25, comma 26, comma 34, then, so the earlier loop of movement code, which you saw, it's off the screen now, but it'd be somewhere up off. And basically, that's the code to find your piece, and then after you've selected your piece, this is the code to go to wherever you want to actually move your piece. So then you're going to see some of that movement code in just a second here, again, right here, just with different variables A and B instead of Y and X. So again, one of our outputs with that same string. Then the movement code with A and B instead of Y and X, as I mentioned. And then output at A, comma B, our new coordinates that we moved to, are plus sign. End. If k is equal to 23, so if we press the delete key right here, just off screen, then I part of matrix A at y, comma x is equal to 2. That's our statement again. Returns the 1 or 0, which we use in answer. Our same output thing. There's a lot of repeated little things in here, as you can see. And if k is equal to 105, which is the enter key, then y minus a store into D and x minus b store into E. So this is where C comes in handy. It's the 10f part. So 10 times the fraction part, so if it's 0.1 multiplied by 10, we're going to get a 1, which means it's our pawn. So this is now the code, which the pawn one is a little bit longer, and I won't read through all this stuff, just make sure you get all the parentheses and stuff. I'll generally talk over kind of what stuff is doing, but that would just be a lot to read and probably be slightly confusing while you're typing. So C is equal to 1. Like I said, is going to be our pawn. Make sure you have that. Then, basically, t is equal to 2. That means you are the lowercase and you want to only go upwards. And if you're on the top row in the uppercase, t is going to be equal to 1. And you can only go downwards on the screen. So it's making sure you're going in the right direction and you're moving either 2 or 1 space. 2 spaces, if it's the first move of that pawn from the original row, then you can go 2. So if all that is true, all that turns out to be, yep, you made a legal move, you're all good, then we're going to store 1 and 2k. Then we're going to take the I part of matrix A at A, comma B, and do sort of the same thing, only this is the attacking code, so you can actually attack diagonally and sideways. And then also 1 store into k. If C is equal to 2, it's going to be slightly different, because now we can move anywhere in the general axes of not diagonal, but just straight up and down or straight left and right. The vertical and horizontal axes. So we're going to then go through all that code, and now this time we're going to only store 1.5 into k. I guess it was 1 before, so this is a little bit more. The 1.5 is basically a marker saying, okay, there's something else we need to check. So 1 means it's all good, and 1.5 means since these pieces, like for example, this is the rook, so it can only go in the vertical and horizontal axes, as I said. It can't jump over other pieces. So we need to check to make sure that there are no pieces blocking its path. And if there are no pieces blocking its path, then we're all good to go. And there'll be a loop specifically for anything that says 1.5 store into k. If C is equal to 3, this is going to be our knight. So if the absolute value of its direction is either 2 in one direction and 1 in the other, or 1 and 2, then you're all good to go. 1 store into k. Since you can jump over pieces, I don't need to store 1.5 in. If C is equal to 4, this is going to be our bishop. It's basically saying make sure the piece, if you're landing on a piece, is not equal to your own piece. All those other ones also have that. And it's going to go in a diagonal direction. Then C is equal to 5 is kind of throwing the rook and the bishop code together. Pretty much that's what it is. And then it's checking to make sure we're not jumping over any pieces, because this is the queen, and the queen can also not jump over any pieces. And then a little bit more code there. So this is like this is the bishop code, and then this would be the rook code down here, and then check both of those if those cases are true. And then this is the code for the king. You can see it's really small. It's basically just making sure that you're just going less than or equal to 1, the absolute value. So if you're traveling 1 in one direction and 1 in the other direction, as long as it's less than or equal to 1, you're all good, because the king can travel 1 space diagonally or 1 space up and down. And then end, if k is equal to 1.5, so this is our loop to check to see if anything is indeed jumping over something. 0 store into u and 0 store into v. Absolute value of a minus y store into theta. If the absolute value of b minus x is greater than theta, then absolute value of b minus x store into theta. So whatever our longest direction traveled is for the rook, and yeah, basically just for the rook, and if the queen travels horizontally. For C, or horizontally or vertically, for C, 1, theta minus 1, u plus y is greater than a minus y is less than a, store into u. So this is a classic example of basically it's the movement code, just with a little bit different stuff for our values to add or subtract to move that along, and then check in each position. V plus x is greater than b minus x is less than b, store into v. If matrix A at y minus u, x minus v is not equal to 0, 0 being there's no piece there. So if you crossed over a place where there is a piece, 2 store into k. End. Then if k isn't equal to 2, k would currently be equal to 1.5, then we have to store 1 into k, because everything's all good. And if k is 2, well then it's just going to loop through until you actually select a legal move. And then we have 3 ends. And then after you've made your legal move, there's just a couple more things to do. I part at matrix A, comma B is equal to 2. Again, our same output thing to output our pieces. If you want to change any of that, just make sure you keep it continuously throughout the program, whatever you change it to. If k is not equal to 23, then matrix A at y comma x store into matrix A at a comma b. So that means our original place where our piece was, everything was a legal move, and you didn't click the delete key right here to exit moving your piece and selecting a different one. So we're going to move our piece from its original position to its new position, and then erase our piece at its original position. If t is equal to 1, multiplied by the fact that t is equal to, or a is equal to 8, multiplied by 10f part of matrix A at a comma b is equal to 1, or t is equal to 2 and a is equal to 1, multiplied by 10f part at matrix A at a comma b is equal to 1, then, so this is saying if a pawn from either side of the board has reached the other side of the board, then 0 store into k, repeat until k is equal to the sum, or repeat until the sum of k is equal to any of these buttons right here. Get key store into k, and end k minus 40 store into k. Matrix A at a comma b plus k divided by 10 store into matrix A at a comma b. So this is the either pawn has reached the side of the board, and then you get to select what piece you would like. End. Output at y comma x comma quote the little tiny, I guess it's just a little square. A store into y and b store into x. Output at 3 plus 2 multiplied by t is equal to 2, comma 16, comma quote, and just a singular space right there. And that singular space is erasing the x on the turn indicator, and then the other one is adding an x to the turn indicator at the appropriate spot. T plus 1 minus 2 if t is equal to 2, store into t. So t is going to automatically get added to 1. So let's say t is 2. So 2 plus 1 is 3, multiplied by the fact that t is equal to 2, which we haven't actually changed t. So since it was 2, now it's going to subtract 2 from our 3, and we're going to get 1. So it's just like a little way to make a binary signal of 1 and 2, just going back and forth. And then we have 2 ends, and that is the end of the program. So that's all there is to chess. I hope if you make this program, I hope you enjoyed it, and I hope you have some fun playing chess. Thank you for watching. As always, if you like the video, I hope you do give it a like. Feel free to comment down below in the comments. I often take ideas from the viewers, so if you have an idea for a future game, go ahead and leave a comment down below. As always, thank you for watching, and I'll see you in the next one.